Okay, hello everyone, welcome back. We have already learned a lot about bipolar junction transistors, how they operate, what their operating regions are, what the different types of transfer characteristics are. So in this lecture, we will be learning in some detail about the field effect transistors. Our approach and steps and arguments will be exactly similar to that of bipolar junction transistors. Okay, just the control parameter for field effect transistors will be different. Okay, so let's get started. The circuit symbol for field effect transistors is this. Okay, all right. This is the circuit symbol of field effect transistors. Compare it with the circuit symbol for the bipolar junction transistors. Okay, you see that there is some difference here. Okay, particularly these are more slanting in BJTs, and there is a gap in the field effect transistors, etc., etc. So these three terminals have names, different names. This terminal is called the gate. Okay, I think it will be better to make comparisons with the BJT while drawing these terminals. Okay, all right, this terminal is called the gate, and in the BJT this terminal was called the base. This is called the drain. The BJT, this was called the collector, and this is called the source. In the BJT, this was called the emitter. Okay, all right, this is the circuit symbol, and from a source perspective, the field effect transistors are our voltage controlled current source. Okay, and the BJTs were current controlled current source. Okay, current controlled current source. So in the BJT, the base current, okay, this current, the base current controlled the collector current. Okay, control this current IB. In the FET, okay, this was the BJT. Let me write the names, I guess. This is BJT, and field effect transistors are called FETs or FETs. Okay, so and in the FET, the input voltage controls the output current. By the input voltage, I mean the voltage between the gate and the source. Okay, we will call this VGS, the gate to source voltage. The gate to source voltage controls the output current. Okay, the output current is the drain current. This time we will call it ID. Okay, exactly similar to the BJT, just the control parameter is different. In the BJT, the input current controlled the, the input current controlled the output current, controlled the collector current IC, IB controlled IC. In this case, the input voltage VGS, gate to source voltage, controls the output current ID. Okay, so from a source perspective, the field effect transistor is a voltage controlled current source. So we draw a field effect transistor like this. Okay, all right, this is our gate, this is the gate, this is the drain, and this is the source, and this is the input voltage VGS, and this is the output current ID. Okay, in the same way what we drew for BJTs was we drew a BJT like this. this was the base, this was the collector, and this was the emitter. Okay, and this was the input current IB, and this was the output current IC. Okay, so in a BJT, the output current depended on the input current through a factor beta. Okay, we call that the gain of the BJT. Okay, so we wrote IC equals to beta times IB. Similarly, for a FET, the drain current is some constant times the input voltage VGS. This constant we call this G. Okay, more specifically GM we call it. M stands for MOSFET. Okay, this is a specific variety of FET, but we don't need to go into the details of that. Okay, so we call this constant GM. Okay, this GM is called the transconductance. Okay, the transconductance of the FET, or more specifically the MOSFET. Okay, all right. So, well, exactly similar to BJT. In the BJT, we had a constant of proportionality or some gain factor. In the FET, we also have a gain factor GM. In the BJT, we multiplied the gain by the input. In the FET, we are also multiplying the gain by the input. Just the input parameter for these two transistors is different. Okay, one is current controlled and another is voltage controlled. Except this, everything else is similar. All right.